All right, so today we're going to talk about analyzing polynomial functions for key features of the function through factoring and graphing using language of analysis. So we're going to be doing describing graphs like we had in the past, except for now we're going to do polynomial graphs. And to start to do polynomial graphs, the first thing you really want to do is you want to factor your polynomial. Why? Because it's going to give me all my x-intercepts. So if I'm looking at this one right here, let's put my pencil on. There we go. So if I'm looking at this one right here, so the first thing I need to do is I need to put this in my calculator to find at least one factor. So go ahead, type this in your calculator, push the graph, and find one factor. So I can see that it crosses, and I'm going to go positive 2, okay? So I know that a factor is x minus 2. Okay, so x minus 2. So first thing I'm going to do is I'm going to put 2 here, and I'm going to use synthetic division and drop my coefficients 1, 4, -4, -16. Bring down my first number, which is 1. 2 times 1 is 2. So this is 6. 2 times 6 is 12. -4 plus positive 12 is 8. 8 times 2 is 16. -16 plus positive 16 is 0. So here I got one of my factors here, x minus 2. And I have what's left. Remember, drop a degree, so squared. So x squared, use the 6 plus 6x. And the last one is 8 plus 8. Okay, and I'm going to go ahead and I'm going to use an x puzzle. So 8 goes up here, and 6 goes down here. So two numbers that multiply to 8 and add to 6 are going to be 4 and 2. Those are my remaining factors. So I have x minus 2. And I have x plus 4 and x plus 2. Alright, so right away from this problem right here and this problem, I have all of my x and y intercepts that I need. Okay, so right here, let's see, get a different color here. So this number right here gives me my y-intercept, okay? That last little one. If there's nothing there, you just end with an x, then it's 0. But this one right here gives me my last one. So I have a y-intercept at 0, -16. Oh, forgot the 1. Okay, and then I have x-intercepts here at 2, right, the different version, 2, 0, -4, 0, and I have -2, 0. And there we go. There's all my x and y intercepts, so that's a good start. So the next thing you're going to do is you're going to put this in your graph, and you can put the original or you can put this one. It does not make any difference, but we're going to put it in Desmos, so I'll be right back with Desmos. Alright, so here we're back. I have this graphed in my Desmos, and I can see that all of my x-intercepts were correct. My y-intercept was down here. Let me scroll down just a little bit for you. There it is. You see it right there at 0, -16. And now I was able to do this in my Desmos. You can't do this. You can do this in your graphing calculator. It's just a little bit difficult, but you can do it. But these points are going to be really important. Okay, so here we go. I'm going to look at a few different things. Okay. So the first thing we'll look at is intervals of increasing and decreasing, just because I know they're the hardest. So when I look at my graph on the left part here, I can see that this right here, right, this part right here, I'm going to get a yellow just to go over it. This up here, I'm going to go like this. You can see that's going up, 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 up until this point, right? So I have an increasing interval, okay, and that is from -infinity to this point right here on the x, right, on the x, so -3, let's call it 3.1, -3.1. Alright, then this part, is going down, so it's a decreasing, and I'll say that is a decreasing interval. And let me go ahead and pull this down a little bit so we can get that point. Decreasing interval from the -3.1, right, where we left off, to 0.43. Bam. All right, then we go up again. We're going up, 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 okay? So that's another increasing, and that is increasing from 0.43 to positive infinity because it does not come back down. All right, so we have that. Now let's talk domain and range. Well, in this case, and not always, but in this case, my domain is negative infinity to positive infinity, and my range is also negative infinity to positive infinity. Okay? Now there's a couple of things that we're going to talk about with these graphs. One, what's the degree of this graph? Well, the degree of this graph is the highest exponent, which is the degree of 3. Okay, degree of 3. Degree of 3. Sometimes they'll talk about the origin of the graph. Does it pass through here? Well, in this case, no, it does not pass through here. So we do not need that. And other than that, you will have all your domains will be this, but some of your ranges may be different, okay? They may have a bottomed out or a minimum or maximum point that you need to look for. In this case, we do not.